Let's investigate systems of linear equations. A system of equations is just a set of equations. Here we have two equations. Notice that both of these are linear equations or lines. So we will be looking specifically at a system of linear equations. And in this solution for a system of linear equations, we are looking for all the ordered pairs that satisfy both of the equations of the system at the same time. There are three possible outcomes for a system of linear equations. The main outcome is one solution set, and that comes when we have two lines that intersect at a single point. This will give us one answer. We will get no solution if the two lines happen to be parallel because there is no common solution or point that satisfies both of the equations. On the opposite hand, we could have an infinite set of solutions. This would come about if both of the lines happen to be exactly the same line. If we are given an ordered pair, we can determine whether it is a solution of the system of linear equations by plugging that ordered pair into both of the equations. And I have done just that, and you can see that in the first equation we end up with a true statement, negative 12 equals negative 12. Likewise, in the second equation, we end up with a true statement, 4 equals 4. Because of that, we know that this solution, the point negative 4, 2, is a solution of both of the equations. Therefore, it is the solution to the system of linear equations. Another way we can look to solve these is by graphing. Since these are lines and we know how to graph lines, we could graph both of the lines to figure out where they intersect. So for example, if we take this system of linear equations, the first line is 4x plus 2y equals 8, and my second line is 6x minus 2y equals 12. I have worked through both of these systems through a T-chart, and now I will look to graph both of these lines. Having graphed these two lines, line 1 in purple and line 2 in green, I can see that the solution to this system of linear equations is the intersection point of 2, 0. I can also notice that in my T-chart, I have that same intersection point. Therefore, the solution to this system of linear equations is the point 2, 0. Another way we will look to solve a system of linear equations is by using the idea of substitution. Substitution oftentimes seems easier, especially when the lines are hard to graph or we can't easily see the intersection point. So, to solve a system of linear equations using substitution, the first thing we want to do is make sure that one equation is solved for a specific variable. And you can see in my equations down here that the second equation is solved for a specific variable, in this case x, and we will take what x equals, in this case 2 minus y, and plug that in to our first equation. Let's take a closer look. So I want to solve this system using the substitution method. So what I first notice is that I have two equations. And in my second equation, I already have one variable isolated or solved for. This is going to assist me in using the substitution method because I will see that this equation, y equals negative 7x minus 4, what y equals will be substituted in to the first equation so that we end up with one equation in one variable. Let's take a closer look at this substitution. So I notice that 6x minus y equals negative 9 is my first equation, and I have taken what y equals in my second equation and plugged that in for the y variable. Notice that I kept the subtraction sign out front of that entire expression. What I need to do now is continue solving this for what x equals. So I start by distributing the negative sign to both of my terms in the expression, getting 6x plus 7x plus 4 equals a negative 9. I then combine like terms and subtract 4 over to get 13x equals a negative 13. And lastly, I'll divide by 13 on both sides to get that x equals a negative 1. I now know what one part of my solution is. Remember, I will be looking for an x, y solution. So right now I know that I have a negative 1 and I need to find y. Because I have found x to be a negative 1, I can now plug that in to one of my equations to find my y variable. It does not matter which equation you plug it into, you should get the same answer if this truly is a solution to the system. In doing that, plugging in a negative 1, I see that my y variable is 3, giving me the solution of an ordered pair of negative 1, 3. You always want to check to ensure that your solution is a solution of both equations, thus a solution of the system. So I have plugged negative 1, 3 into both equations and found that they are true statements. Thus, negative 1, 3 is the solution to my system of linear equations.